Do you feel intimidated by sequence questions on GMAT, which seem very mathematical in nature, where sequences are defined in terms of a and x and n minus 1 and n plus 1 and so on? While these questions might seem a bit scary at first, they are usually pretty straightforward. All you need to do is just get started by generating the first few terms of the sequence and you're bound to see a pattern emerging. In this video, we take a look at one such hard data sufficiency question. You need to be careful about one step though, because if you overlook something while solving this particular example, you just might not see the connection between the numbers that you are deriving, and that might make it a lot harder for you to answer this particular question. And by the way, there are 6 different types of sequences that GMAT has regularly been given candidates. I've covered all 6 types in a separate video. The link to that video is given in the description below, and you can have a look at examples of the other 5 sequence types as well. The links for these videos have also been provided in the description below. Remember, sequences is a very important topic for GMAT. Questions have regularly been appearing from this topic, and hence it is important that you take sequences seriously and thoroughly prepare for this topic. Okay, so this is the main part of the question, and this is where the definition is given. We have to understand this notation. These are the terms S1, S2 up to Sn, such that Sn is 1 over n minus 1 over n plus 1. So if I put n as 1, I should put n as 1 here. If I put n as 2, I should put n as 2 here. And that's how we can generate the sequence. And the restriction on n is that it's greater than or equal to 1, which means the first term will be S1, the second term will be S2, and so on. And now there is some k also which is being defined, which we'll come to later. First, let's understand how the sequence is being developed. The first thing that you should do whenever you deal with any such question on GMAT is to just start writing down the first few terms. What is likely to happen on most questions is once you write down the first few terms, you will see a very clear pattern emerging and you can quickly extrapolate. Okay, so let's get started with S1 as our first term out here. S1 is 1 upon 1, which is 1. Or let's write down the whole thing, 1 upon 1 minus 1 upon n plus 1. We have taken n as 1, so 1 over 2. Okay, now there are 2 things you can do here. One is leave it as it is, and the second is equate it to what it works out to be. Ideally, don't be in a hurry to equate it to something, because in such sequences, again, the terms as they shape up can also lead to many cancellations happening along the way. So for the time being, at least, let's keep it as it is, 1 over 1 minus 1 over 2. Let's write down the second term. When I put n as 2, it is 1 over 2 minus n is 2, so 1 over 3. Okay, and something is already evident that this term here and this term here, this is a negative half, this is a positive half. So when I add up S1 plus S2, you can already see certain cancellations happening. Okay, so that is the reason we have left it as it is. S3, the third term, one over 3, 1 upon n, minus 1 over 4. Okay, and already we can see that these two are going to net off, and this is how the sequence will continue. And it's also a very clear pattern: half minus 1/3, 1/3 minus 1/4, 1/4 minus 1/5, 1/5 minus 1/6. And it's very, very easy now to extrapolate any other term, even if you need it immediately. Now let's come to the question. The question is asking us, if k is a positive integer, is the sum of the first k terms greater than 9 over 10? This is our reference point. Statement 1 alone tells us k is greater than 10. If k is greater than 10, then on the minimum side, the lowest possible k will be 11. So let's see what will happen if we go all the way up to K11, in fact, the last term, let's just write it down first, S11 will by definition be 1 over 11 minus 1 over 12. And then we will start to add up all of these. So what you will see is that this will cancel off with this will cancel off with this will cancel off with a 1/4. Here there'll be a 1/11th in term S10, which will cancel off with the 1/11th, and this will remain. So final total will be 1 minus 1 over 12, which is 11 over 12. So on the lower side, this is the total we are getting, 11/12. The question is 11 over 12 greater than 9 over 10? And clearly the answer is yes. So at the lower end of the value k, possible value for k, we are starting off with a yes answer. As we increase k to 11, 12, 13, 14, 15, it can be any number above 10. What we will end up doing is something like 1 minus 1 over 14 when k is 13. 1 minus 1 over 100 when k is 99. And this subtraction, all these numbers, the fractions that you end up getting here are definitely going to be higher than 9 over 10. In fact, we are going to get bigger and bigger fractions because the subtraction, the last term, which is ultimately getting subtracted, will become smaller and smaller and smaller as the n value increases. So we are guaranteed to get a value higher than 9 over 10 from statement 1 alone. So statement 1 alone is very much sufficient to answer the given question. Now we have to look at statement 2 alone, which tells us k is less than 19. If k is less than 19, it could very well be 11, which we just considered. And if k is 11 out here, if we assume k as 11, then this is the result that we just got, which means with k as 11 as an assumed number, which is below 19, we can easily get the yes answer to the above question. We don't need to do any fresh rough work. And with k less than 19, it could also be 1, the smallest possible k, because k is a positive integer. That's it. So it can come as low as 1. And when k is 1, there's only one term in the sequence. So the value of the sequence is 1 minus half, which is equal to half. And when we go to the question, is half greater than 9 over 10? The answer is no, it is not. So statement 2 alone, with 11 we get a yes answer, with a 1 we get a no answer. So we are not getting a unique answer from statement 2 alone. Therefore, A is the answer to this particular question.